welcome everyone. Good morning. My name is Mikaël Barbero. I'm the head of security of the Eclipse Foundation, and today we'll talk about security. So security is a broad topic, right? So we will focus on open source, on the supply chain security, and without further ado, why does it matter? It may not be a surprise that it doesn't work. Without any surprise, it's all about the money. If cybercrime was a country, it would actually be the third world economy today. So just behind China and the US. And what we are witnessing today is actually the greatest wealth transfer in the world. It has been estimated that by 2025, the cybercrime would totalize an amount of damages of 10.5 trillions of dollars. It's not millions, it's not billions, it's really trillions. And it's still on the high, the slope is really high, so we need to be aware about that. That's our adversaries and that's their funding, so we need to go against that. And if we look at the profile of the attacks today, they are quite shifting their target and their methodology. The supply chain security attacks, the supply chain attacks are actually very increasing, highly increasing. The year-over-year average in the last 3 years is 742%. And we could wonder why they shift their attacks or their method from the classical approach to directly target an app in production to the supply chain. And that's just because they are good engineers and they want to optimize what they do. And they know that by attacking the supply chain directly, they increase the blast radius of the compromision that they do. And of course, they have a better return on investment. So let's go back a little while back with the SolarWinds attack. So I guess that everybody has heard about the SolarWinds and the Orion, the Orion software. And if we look at the time scale, how long this attack has been active in the wild, we've seen that from this timeline, the victims were actually downloading and using the compromised software for more than 6 months. And Orion was actually a pretty successful software, or is a pretty successful software. So running a compromised software in a large number of companies for 6 months can be quite damaging. And if we look at the actual customer of Orion, the SolarWinds Orion, 95% of the Fortune 500 companies are using, or were using, I don't have the number today, but at that time, 95% were using SolarWinds Orion. Among those, some very well-known companies, and yeah, all of them have been pwned. But not only that, also some US agencies were using Orion. And guess what? They have all been compromised for 6 months without being detected. So when we talk about blast radius and scale of attacks, supply chain can be very effective. But why was SolarWinds or Sunburst, the name of the attack on the Orion software, a supply chain attack? That's because the threat actors actually targeted the build system of SolarWinds. There was a build machine over there with a weak password, and the threat actors managed to get into and wait silently for a couple of weeks to see if they were detected. And once they identified that they were not detected, they started to change the way the build were behaving. So the thing is, the build, the output of the build was actually exactly like any other build. It was actually signed by the SolarWinds certificates. So customers, they didn't have a clue to know that the SolarWinds, the Orion product was compromised. And that's everything that matters with supply chain attacks. The customers, the end users, usually don't notice anything about the attack until it has been detected by the producer. So SolarWinds is a proprietary product, so you would ask, okay, what is the relationship with open source and why does it matter? That's because open source has won. We all know it. Open source is actually part of 90% of any software, be it proprietary or open source as well. And we are part of a global supply chain that across industries, community, and so on. As open source is part of this global supply chain, it would be wrong to consider that open source is the issue in the supply chain security. We need to treat that as an industry-wide problem. So, what is a software supply chain, by the way? So here we have a diagram from the SALSA SLSA framework. We'll talk about it a bit later. So typical or simplified view of the software development lifecycle. And when we look at even such a simplified diagram, where are the threats for supply chain attacks? That's basically everywhere, on every node and every link. So that's pretty scary. But what is even more scary, or scarier, is that we have actual dependencies. And dependencies they have their own supply chain. So we find, again, all the threats at every level of dependencies. So it becomes a mess, right? It's almost Halloween, so let's talk about some scary story, and I hope I won't scare you too much. So let's start with the first chain between the developer and the actual source code repository. You may have heard so I will focus on only the attacks from the last couple of years, so they are fairly recent. You may have heard from 2 years ago this hypocrite commit thing, so where researchers were deliberately pushing code or sending PR with malicious code or with bugs inside it to identify if the review process was strong enough to detect those. So that's one way a threat actor could actually behave, is to send something that looks like a feature or a patch, but actually contains a vulnerability. One way to mitigate those kind of attack is, of course, to have more persons reviewing the code to identify issues, but also to run static code analysis. For instance, the free after use thing should have been detected by some static code analysis. The second thing that can happen at this level is impersonification. So you may have heard from 2 years ago again this story about the UA parser JS. So it's a JS library, node library, created by Faisal Salman. 10 years ago, well maintained, very good track record of contribution and so on. Everything was good until at some point something happened on the dark web. So someone posted a message on the dark web saying, okay, I have an account, credentials, no 2FA, no two-factor authentication, 7 million installations per week, or quite a large software, or widely used software. Place your bid. And guess what? It has been bought by someone who actually used Faisal credentials to publish hijack or malicious code into the library. And where you could think it's okay, someone look for the dark web and found credentials, so they put something quite easy to detect. No. They are pretty smart, and they get better at pushing stuff that are really hard to detect. So for instance, in this case, the threat actors pushed 3 versions of the library simultaneously, one for each of the minor branch, because they know how we work, and we always use version range to our dependencies. So any user of the library, independent of the version they were using, got the update and got the malicious code. So in this case, that was pretty bad, because the dependency actually was stealing credentials on the operating system and the cookies as well. So it could retrieve some sessions, some credentials, and so on. So an easy way to circumvent that is to have two-factor authentication on your account. Another kind of thing that can happen at this level is not a new malicious actor that goes into your code, but a developer that goes wild. So meet this new project, new JavaScript project again by Brandon Nozaski. Again, widely used project, 1 million of weekend downloads, maintained for years, 8 years, high profile. This guy actually maintained 40 other packages on NPM with a lot of downloads and so on. But on March 2022, he added some comms that wipe your disk if you call his library from Russia or Belarus. So that was just after the invasion of Ukraine by Russia. Yeah, I'm doing that for free. It's my code, so why not? I can protest the way I can. So it's up to you to decide now if you still want to use this code, or if it's legit or not, but that's a risk for you whenever you depend on such an open source project. So one mitigation would be to maybe not trust single committer projects, or maybe to have to ensure that every new commit is actually reviewed by 2 or more committers, or 2 or more persons. Last thing at this level is maintain a change. So again, a node project, so Event Stream by Dominic Tarr, a very widely used project. It was not well maintained. The guy didn't have the time anymore to maintain it, so someone a nice benevolent guy asked, okay, I can take care of it, and you maintain it from here on. So Dominic was really keen to get rid of it and to have it thrill under a new benevolent person, developer, and he gave him all the credentials on the GitHub account. The thing is, it was a threat actor, and he added a dependency to this package that was actually trying to steal some Bitcoin on the target. And it was impossible for Dominic to retrieve or to roll back this stuff because he was not owning the code anymore. So guess what? At the Eclipse Foundation, if you have a project, we are already pretty well immunized against that, because with a good governance and no way for a single person to decide to transfer the ownership of a project to someone else, it would not happen. So that's only for this link, right? That's pretty scary already. And we still have all these other nodes and links. Something I didn't mention, and I don't think we have big story yet on that front, but think about I guess you all use IDEs to develop codes, and you use plugins, stuff like that. Guess what can do a plugin developer, a malicious plugin developer, if you install that in your IDE? Or maybe you use some fancy shell, like OmaZSH or thing like that, to have really nice shell. Do you trust everything you install from those projects? Yeah? And they have access to all your credentials, right? They have access to your bash history, they have access to your OS vault, and so on. So I have many other scary stories. I will go through some of them very quickly and some of them in a bit more detail. But at the source level, that could be the good old server being compromised. So for instance, in the PHP case, the Git server hosting the code has been compromised. Someone managed to make commit without having any permission on the Git repo, but he has access to the machine as root, so he was able to do that, and he he used the name of the creator of PHP to create those commits. And luckily, it has been detected quite early, so it has never been deployed as a production version. So of course, protecting your source code repository is something that is pretty obvious, but one way to be able to detect that without having to check for all commits one by one would be to enforce signature of all your commits. In this case, even if the threat actor was inside the Git server, he would have been able to create or to craft a Git commit with the name of the creator of PHP, but of course, he didn't have the private key to sign this commit in his place. Second link between the source and the build. So that's where your infrastructure is being compromised. So in this case, it was webmin that had been compromised. So webmin, for performance reasons, they tried to, they were not redownloading or recloning the source code repository at every single build. They were keeping a cache. So someone get into the machine and they modify the file that is not updated very frequently, so that it was not updated on the next git fetch. And they managed to push some code in the final results because of this poison cache. at the build level. So one way to have that is to only build on ephemeral machine and to always build from scratch, of course. At the build level, so we've seen the SolarWinds example, but something that is quite interesting is something new from this year. You may have not heard about it. It's repo jacking. So you may know that the GitHub Action stuff, so how to build project at GitHub. So that's a workflow, a pipeline to build, where you describe your build steps. And the nice thing is that you have a marketplace where you can reuse steps for your build, so you don't have to define it all by yourself. That's pretty nice, right? We don't want to reinvent the wheel. We want to reuse. Besides that, there is something at GitHub is that you can rename your account as well. And yeah, I created my Eclipse account when I was a student. So I use a name that I found cool back in the days, but now I want to change my name because I'm in corporate world, so I want some more business-friendly username at GitHub. But one thing that you may not have read yet is this part in the GitHub description. Whenever you change your username, GitHub creates redirections, but the old username is usable again. So what happens in this case? You have Cyberbob, who wants to change his name to sblock, and any user of the old user space, so using an action to build his project in this namespace, the Cyberbob, will get redirection to sblock and everything is fine. But if the threat actor actually reclaim the new username, then the link, the redirection between the two is broken. And the end user doesn't know anything about it until something bad happened on the original repo. So what they do usually, the threat actor in this case, they stay exactly the same. They keep the same code. And they wait for the user to actually pull a new version because they use, of course, a tag, not a SHA of a git commit or specific commit. So whenever the new the malicious code in Cyberbob is being pushed, they will be using the code in the build pipeline. And the build pipeline has, of course, access to many things that you don't want to share with a malicious actor. It has access to your AWS deployment keys and stuff like that, so you don't want them to be readable by anyone. So one way to work around that is to depend not on Git action tags, because tags are not immutable, but on git commit SHA whenever you use a GitHub action. And by the way, that's the same for Docker images. Don't use tags when you depend on Docker images. In the from directive, use the SHA of the image. Jenkins miner, so that's another story where the Jenkins, the people were running an old version of Jenkins with many vulnerable code, many vulnerabilities, so some threat actors took opportunity to actually inject some code mining, and they were paying the bill for. They were using the bill, the cloud bill of the end user to mine by Bitcoin. And now we are arriving at dependencies, right? But we're using open source, so we know that, right? Open source is vulnerability free because we all look at the source code and so on. Of course not. We have all those bad story of vulnerabilities in the code, so there is nothing we can do about that. We will have vulnerabilities in the code, and sometimes vulnerabilities that break your supply chain or that make your supply chain a threat vector. So what you can do to minimize the time to recover, the time to remove the vulnerabilities, to actually have an SBOM, to know what you embed in your software, and to do a continuous analysis of those dependencies. Same, threat actors use typo-squatting or brainjacking. So typo-squatting, you may know that from a couple of years ago, where people were buying domain close to existing domain just to make you go to a website that looks legitimate, but we're not actually. And they do the same in package manager. So you have Electron rather than Electron, in case hoping that you will do a typo in your package JSON. Or you have brainjacking in the case of Twilio NPM. The Twilio API is just Twilio and not Twilio NPM, so they use the brand to make you confused about what you get. And something even more advanced than brandjacking or typo-squatting is dependency confusion. It's something from last year. A researcher did this analysis and managed to find what are the name of the artifact that companies are using internally. So whenever you do a product internally in a company, you use open source component and you use private component that you put in your own registry. What happens if this private component with a private name, so comme Apple private blah blah, is available on the public repository, in the public registry? You get a dependency confusion. The resolver, most of the time, will actually go fetch the private artifacts from the public repo. So you can deploy anything in all the researcher managed to deploy any code he wanted in Apple, Microsoft, and Google code base thanks to this dependency confusion attack. And so he was a white hat. He didn't do malevolent action from this, but we've seen many copycats right after the publication of this blog post. So you want to sign everything and verify signature. That's an obvious thing, and to verify the provenance of all the dependencies you fetch. So we have many other kind of attacks. I will go very quick on those one. So we have this story about CodeCove that happened right between the package, the build and the package thing. So CodeCove is a GitHub app that has been compromised, and of course it had access to many of your credentials. And so bad thing can also happen at the package manager level. So you can have an attack that uses expired domain to take over a package on registries. That's something pretty nice, actually, if you think about it. So some committers use their own personal emails. They don't use Gmail or Hotmail or whatever. They use pumping@lastname.com. But sometimes you forget to renew your domain, so the domain expires, and anyone can, again, buy it and recreate this address email, and they can then use or ask for a password recovery with this email address that they know own. And that's exactly what happened with the CTX project. They recovered the credentials from PyPI, and they published a new version with malicious code. So again, one way to mitigate that, use 2FA, even if the committer use an expired domain email with two-factor authentication, the attacker couldn't get access to the repository. And finally, you have something at the consumer end. So of course, you can put the brandjacking and the dependency confusion at this level as well. But that's more for end app or for end users whenever they search for it on a package manager like PyPI in this case. There is something on those package manager pages, on the project pages, where it's displayed the number of stars and forks and so on to help you decide whether it's something that should be trusted, right? So you have something on PyPI, you have the same thing on NPM, and you would think that, yeah, okay, so this project is pretty nice. I can use it, it's already downloaded a lot, so it's trustful. The thing is, for instance, in the case of PyPI, there is no validation of the link that you put. So you can actually create a new package and put the link to a repo that has a lot of stars and just inherit the popularity of any package. So if you combine that with some typo-squatting or brandjacking, you can end up with quite a catastrophe. So, quite overwhelming, right? What should I do? The good thing is the Eclipse Foundation is here to help. Our goal and our vision is to help our project implementing the best practices, so to help you implement all those workarounds to mitigate the threat on your supply chain. But what we acknowledge as well is that simply putting the burden of implementing those workarounds on you who basically don't want to deal with that. I guess you want to fix bugs and add new features to your code. So it's not desirable. We don't want to put new threats, new barrier to entry to your releases, for instance. So we are creating a set of services, tools, and best practices that will be a core service of the Eclipse Foundation to any of its projects. And of course, we won't do that from scratch. We won't even invent anything. We will reuse the industry standards and what is known to work well. So for instance, we will rely on the SALSA framework. So I already talked about it for this diagram. SLSA, so it's a framework for improving the best practices, or to actually implement the best practices for the supply chain security of your project. So it's the barrier to entry is very, very low. The level 1 is very easily achievable, and then you can gradually improve your levels with a very clear indication of what you need to do. So that's a summary of the various levels. We can go actually a little bit more in details with each requirement for each level. So you can see that for instance, for SASA level 1, you just need to have a scripted build, so a makefile, a shell script, whatnot, and some provenance for your build. So this build or this artifact has been created from this commit, and it has been built by this script, and triggered by, for instance, this event from GitHub. So that was a push to the main branch. And what we did recently at the PMI, so at the project management infrastructure, so you can now declare your SALSA level compliance directly for your project, and it will be displayed on your project page right away. So we don't have yet anything to describe how you comply, but that will be the next step. We'll provide something that lets you link to proof that you comply to such a level. So some part of SALSA requires you to, for instance, to generate provenance attestation or provenance of your build. For that, there are already some things that exist for GitHub native projects or GitHub project that use GitHub Actions. It's called the SALSA GitHub generator, and it's already a SALSA level 3 attestation that generates an attestation for SALSA level 3, so it's pretty complete, and you can already use it today. At Eclipse, many of our projects still use Jenkins, and there is not a lot of things happening at Eclipse. So we've just started to create a shared library to generate this attestation of provenance. So what git commit this build is coming from, which user triggered the build, and which event did that as well. So that will be available very soon. It will be something like that. So in your build, your Jenkins pipeline on the left, you will ask to generate the provenance for some jars. You will reuse whatever is in your build environment and generate something, such a document. So it's a standard which is called in toto. I won't go into details. It's really just something that is promoted by SALSA, but not mandatory. But we will, of course, reuse such a standard. Something that is required also at some levels of SALSA is to have a SBOM, so a software bill of materials, so listing all the dependencies that you're using. And we have an initiative at Eclipse under the Eclipse ORT project that actually scan all of our repository continuously and generate SBOM for them. So that's not a perfect solution because you have the SBOM for the head of your project, so it's not necessarily exactly what you are releasing, but that could be a good start to actually embed the SBOM generated by ORT into your release. So this is an example of a SBOM, so that's for Jakarta annotation API, and you can see that you have all the components, all the dependencies described with the license and so on. And we have also many other parts that we want to improve, and for that we have a bit less of a framework, but we will just do that iteratively, so we will start by measuring and improving iteratively. So for measuring, we are using 2 projects from the OpenSSF, the Open Secure Software Foundation, called Scorecard and All-Star. So both are very similar, but All-Star provide some auto-remediation by creating PR automatically on the project. Currently, we've mainly focused on scorecard, but we will ask project if they're willing to install All-Star as well. So we've run scorecard on all of our projects, and scorecard, when you give it a Git repository, it gives you a score. This score represents the security of your supply chain. So it's a nice way to start, to have a first measurement of your project, and this is the results of all the GitHub repo of Eclipse projects. So you see that we are doing not too bad, but not too good either, right? But of course, we can go into details. We have more information about which threats are actually present in our repositories. And we've identified that we have two main threats at GitHub for Eclipse project. Is first token permissions, so projects that use GitHub Actions have higher permissions or that they require on their user token. So basically, the GitHub workflow has write permission to the repository while they wouldn't need to. And that's a threat, of course, because then if some malicious code is injected in the pipeline, then they can write anything to the repo. And the other thing is the branch protection. So the main branch is not protected against force push, is not protected against, there is no mandatory two committers review before pushing and so on. So that's the two main things we want to focus on and help our project improve their score. For that, we will use two things. So the first thing is a collaboration with a startup called Step Security that run also scorecard on a regular basis on our repo and let us create pull requests to fix some of those issues. So for instance, it can create PR automatically to change the permission of the token or put the SHA of the GitHub Actions rather than the GitHub tag, the Git tag. And for branch protection, as it's not really in the code, right, it's the repository settings, we are developing a tool to help us manage the repositories at scale. So currently at the Eclipse Foundation, we have 50 organizations and 100 GitHub repositories. We cannot do that manually already. And with the deprecation of Gerrit, we will have even more projects and organizations created. So we need a tool, and this tool, we call it Autodog. And that is basically as code management of GitHub organization, where you can define rules for branch protection and also default values and settings for your organization. So the nice side effect of this is that you won't have to open a desk ticket to ask us to change something on your GitHub repo. You will just have to create PR. You can just create PR and ask for some changes. Of course, we will ask project to activate two-factor authentication, so that won't be an enforcement at first, requirement at first. We will ask project to, try to demonstrate the benefits of activating two-factor authentication, and hopefully we won't have to enforce it. Project will be willing to switch to that. And finally, we are running some security audits on our project. So we are providing security audits as a service, and for that we are relying on a company called Hostif. We are partnering with a company called Hostif. Hostif is pretty well known in the industry, in the open source industry, to have already run a bunch of security review, security audits on many projects, many well-known projects, so OpenSSL, Sigstore, CRIO, or Flux. And we've already started the work to audit, for instance, the Eclipse ID P2 GPG process. So there has been a new signing process in the GPG P2, and that has been we started the work for the security audit. So the key takeaways of this presentation, it's a jungle out there, right? Hopefully you're a bit scared now. And don't forget that the threat actors, they are improving. They are getting smarter and smarter, and they get into, they use everything they can. Think about the GitHub username change is just scary as, very scary. Supply chain security is very hard, and hopefully we will be able to provide services and tools and best practices to help you be better. So I think I have 20 seconds for one question. No, we have 1 minute for a question. Yeah, sure.
I have the perception that the really is the implementer when something bad happening, some liability, eventually depending on the have a risk. There is some initiative because today first making this cheaper because it's not always cheap depends on the country, the digital but it's really certified name and so many. And the second is adding an index, let's say, okay, your dependency are 50% assigned and we know who is in order to push or give a benefit to the people that assign the package.
Okay, so excuse me, I don't get the question.
I didn't see here a lot of initiatives regarding the digital identity. You can still impersonate. This is a big problem.
Sure. For sure, so the question is, we don't address necessarily the digital identity. So first, at the Eclipse Foundation, we know our committers. You have to fill paperwork and you have to give your real name and your employers and stuff like that. So we know our committers. In the wild, there is not something that we can impose. And even if you know the exact identity of the committer of the developer, think about the protestware. Someone can just flip and...
Yes, but let's say you reduce a lot, there is one protestware and there is all the rest.
Yeah. And so one way I foresee that will happen in the upcoming years is that threat actors will actually act for a couple of months or years as nice people who actually provide features and patches and real one, and they will flip to something bad. And
Eclipse or is making some agreement with our organization or is often, okay, we can offer, let's say, a service with a minimal payment, digital identity that can be trusted, like a trust, so you can sign in the package of Eclipse, but also Pipe, Rust, etc., and improving and pushing the community of open source to adopt the digital signing for every patch.
Yeah. So that's actually one thing that we will start to do next year. So there is this project, Sigstore, that lets you sign thing without having to have a key. You sign with your identity by connecting to an identity provider. So the public instance of Sigstore lets you connect via Google, Microsoft, or GitHub. We will have our own Sigstore instance at the Eclipse Foundation with our own identity provider that connect to the committers. But with an identity provider, a trusted identity provider like GitHub or Microsoft or Google, you should be able to improve the situation a little bit. But yeah. Yeah. Sure. Agreed. Last question. Thank you. I think we're out of time, but I'm here until tomorrow evening, so feel free to come to me if you have any questions or comments. Thank you.